All right, welcome back. I hope that coffee or tea or whatever you had was nice and refreshing. So let's get into this example. Real data that we have here, these are real ages of 8 random people in the US government. Okay, so we got a little bit of everything here. You can see that the range of the data is pretty wide, pretty big, right? The youngest person here is 30 years old, and then the oldest is 86. Good Lord. So instead of having to look at this and just sort of say, like, okay, whatever, let's calculate some summary statistics so we can get a better idea of what the whole picture looks like. So we're going to be calculating the mean, the median, and the mode. So before I do it, and before we move on, I encourage you to do this yourself and just see if your answers and my answers are the same. In this case, you want to make sure that you do get this right because this is a very important concept in statistics. So the rest of statistics is, fairly subjective, very opinion oriented, but there is some stuff that you want to make sure that you get right, which in this case is stuff like the small math between getting the mean, the median, and the mode, and whatever. So let's do the median. No, let's do the mean first, just because that's the most math intensive. So let's recall that the equation for the mean, for the sample mean, is x bar equals the sum of the xi's, so all the data points you have, starting from the first one to the last one. Okay, and that's that. And then you just divide that by the number of things that you have. Okay, so let's try to keep this as organized as possible. Okay, so we have n. That's the easiest one to figure out. That's first off, that's given to us. That's 8. But we could also count 1, 2, 3, 4, 5, 6, 7, 8. That's all fine. That's all good. And then we need to move on to the sum here. Okay, so the sum of the data points. And I like to break things apart and piece them back together at the end, right? So I like to find the individual pieces first. You can do it however you want. I recommend that, keeping it as organized as possible, I think is the best way. Okay, so however that looks for you is however that looks. So we've got the sum starting from the first one. And since we have 8 points in our data set, we'll just write an 8 up here instead. And let me be more elegant. There we go. So the sum from the first to the 8th, which is the first to the last, okay, xi, okay? And what that looks like is just taking the first one, so that we have our first data point, 53, plus our second data point, 72, plus 78, plus 78 again. Let me make sure I'm not making any mistakes. Plus 30, plus 55, plus 70, plus 86. So that's all cool. That's all good. And just to double check, I've got everything. I'm going to count. So I've got 1, 2, 3, 4, 5, 6, 7, 8. I'm good. Cool. All right. So then I just want to take the sum of all of these things, and that turns out to be, 522. All right. And then I just want to take this value, 522, and divide it by 8. Divide it by 8. Okay. Cool, right? And that's that. So just a little bit of arithmetic later. 522 divided by 8 is 6. Let's see, I'll do it in a different color here. Is 65.25. And we'll put the units on here too. 65.25 years. Okay. Very important that we put the units on here, but that's our answer. Okay. So the mean age in this sample is 65.25 years old. All right. So that's pretty good, right? That's not too bad. The formula, again, looks a little nasty, but it's not too difficult when you break it down into its components. Okay, so that's all cool. Oh, also a quick aside. I did this on my phone calculator. You can do it however you want. A phone calculator is fine. If you have a TI-85, that's cool too. You can do it, on the computer, wherever. Most of the things in this class, and I say that with a kind of an asterisk, but I think everything in this class you should be able to do on your phone calculator. Now, just make sure that you can do things like square roots and squares and all that kind of stuff. And also, it's a little harder it's harder to make a typo on like a TI-85 or whatever, because you can feel the buttons. On a phone calculator, just make sure that you're not making any typos, because with touchscreens, it can be a little bit, or at least I found that it can be easier to make a typo. So just keep that in mind. Okay, so we've got the mean. We've got the mean age, 65.25 years. Oh gosh, another aside. Decimal points. When we get into more complicated, not too much more complicated, but more complicated math, we'll be getting in. We'll get values that have like really long decimal points. I think that 2 is fine. I think at least 2. If you want to do 3, that's okay. I don't have like a specific rule for that, unless I tell you to go down to some decimal point. 2 is fine. That can be your default for this class, and that's all good. Okay. So we got this math out of the way. We got the mean out of the way. Let's do the median now. Let's do the median. Okay, so this is just a process, not a whole ton of math, if any. But the first thing we want to do is we want to order from the least to the greatest. Okay, so in increasing order. Okay, so this is where you can make a typo just by doing it out by hand fairly easily. So just make sure, take your time. I am gonna take my time here, and also on tests. Well, maybe not on tests, but on homeworks, I'll give you the data in order, so you don't have to do it. But just make sure that you remember that if it's unordered, to put it in order, especially for the median. All right. So let's do that. So we have our lowest value is 30. The next, the next lowest is 53. And then the next is 55. And then 70. And then 72. And then 78. 78 again, right? Even if it's duplicated, you always write them out. And then the last one is 86. So let me double check. 1, 2, 3, 4, 5, 6, 7, 8. Sweet. All right. And then I just want to whittle away until I get to at least the middle pair of values or the middle value. In this case, we're going to get a pair because we have an even number of data points in our sample. So the way I do this, and I think it's the easiest way, is you just start at the end, each end, and you block off 2, right? Then block off another one, and then do it again until you get into either this situation or you just have one value left over. Okay, so what do we do here? Well, recall that if you get down to 2 values and there's nothing else you can do, you just take the mean of these 2 values. So the mean here would be this plus this, so 70 plus 72, divided by how many there are, which in this case is just 2, right? And then that turns out to be 71. Cool. All right. So our median value, median age, we'll say, is 71 years old. Very cool, right? Just so neat. 71 years old. Okay. Cool. That's all good. That's all fine. So what we did, we just ordered it from smallest to largest. And then, since we whittled away and then got down to just 2 values, we took the mean of those 2, and that's our median. So what we say here, and we can do like a little interpretation. Let me see. Yep. Okay. Our interpretation here is that, let me kind of do that too, is that 50% of the data is below. Actually, we can be even more pointed, more specific. 50% of U.S. Government people in the sample is below 71 years. And then everything else, just copy and paste that. We say above 71 years. Okay, so that's the kind of interpretation here. If I ever ask for an interpretation, this would be, what I would like to see. So in this case, 50% of the U.S. government in this sample is below 71 years old, and then the other half is above 71. Okay, so 50% below, 50% above 71. All right, easy enough, right? Easy enough. And then lastly, what we want to do, and here's how I'm going to get fancy here. Yep. Okay, and then check this out. Yes. Booyah. So cool. Okay, so let's do the mode now. The mode is the easiest, I think, because all you need to do is just look for the most frequent number occurring, right? So most frequent. I'm so sorry for my poor handwriting too. I wish there was something I could do. There is. I guess I could just like practice more writing, but I'm not 5 years old, so even though I write like a 4-year-old. Okay, so we just want to find the most frequent value here. Okay, so if we just go along our number line and we see here that, oh, look at that. It's 78. Oops. It's 78, right? So our modal age, or our mode, what? Our mode is, I can write that better. Look at me struggling. Our mode is 78 years old. Okay. So let's see. Yeah. So let me do this. Here's our summary. Okay. Jeez. Here's our summary. Okay. So our mean was, what was it? 65.25, I think, right? Yes. 65.25 years. Okay, and then the mode was 78 years. Okay, and then let me be consistent here with color too. I know that this is like nitpicky, but I think that color coding things is real nice. And, I think it's good to get in that habit. And then the median, 71 years old. Okay, so that's all fine. That's all good. So these three values represent the same thing, right? They represent the sample of 8 people that are in the U.S. government. But they tell us different stories. They're all legitimate ways of calculating and summarizing data. But depending on what our story is, whatever our narrative is, we might choose to use one of them over the others. So let's say that I was arguing and I was saying that I think that the U.S. government is too old. It's too old. What value do you think I would be reporting to back up my claim? Well, I personally would choose the mode here. And the interpretation there, when I tell people, I would say, I think that the U.S. government is too old. And I have stats to back that claim up. In fact, the most frequent age, the most common age to see in the U.S. government in a sample that I took is 78 years old. Okay, that's pretty old, right? And that backs up my claim legitimately, okay? But that's leaving out some of the story, okay? So let's say that I was making another argument and I was going against that. I was going against saying that they're too old. I said, okay, maybe not. In fact, 50% of the U.S. government is less than 71 years old. Okay, that means that 50% is also above 71 years old, but still half is actually below this one value that I just gave. Okay, what does that tell us though? That only tells us the middle point, the dead middle point. That doesn't really tell us anything about, the floor, where we see here that the floor is 30 years old. And it doesn't tell us anything about the ceiling either. The ceiling is 86, right? So you have 50% of the data from 71 to 86. That's a big clump, right? And then, so that's a lot of old people. And then you have more spread out ages, maybe, between 30 and 71, okay? Just food for thought, right? Still a legitimate way of calculating and summarizing data, but it tells a slightly different story. And then the mean, I say, okay, well, the expected value, if you were to go up to anybody in Congress or anybody in the House of Representatives or wherever, and you were to point at them and say, I think that you're 65.25 years old, well, you probably would be somewhat correct. You would be in the ballpark, we would say. But you still have a chance of being wrong, and you have a chance of being really, really wrong, right? Especially if you were to point at the person who is 30 years old, AOC, right? Then, you'd be way off. And we'll talk about that in just a little bit too, right? So you have three different values that represent the same thing, but tell you slightly different, tells you a slightly different story. Okay. So that's fine. However, each one of these values has some pros and has some cons, right? From a storytelling perspective, we just kind of went over that, right? Whatever fits your narrative is whatever you use. But there is some mathematical stuff that happens too that I just want to briefly describe that sort of points out some sort of like shortcomings here, okay? So let's say that, this person is not 86 years old. That is the actual age. The oldest person in Congress is 86. Or let's see, I guess a representative out of California is actually 86. But let's say that, we accidentally made a typo. It's actually 76. Okay. So let's recalculate, and I pause the video to do this yourself. But let's recalculate some of the statistics, the summary statistics, the mean, the median, and the mode. Let's redo it, okay? So let's do the mean first, okay? And I'll just write out the equation. Okay, so that's our equation for the mean. So let me do this. So the mean is going to be 53 plus 72 plus 78 plus 78 plus, 30 plus 55 plus 70 plus 76. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're good. And then we just divide that whole thing by 8 still, right? And I will put parentheses around here just to denote that if, you're supposed to add up the stuff first and then divide, okay? And then I don't have, let me see, I gotta do this actually by hand in my own phone calculator here. Let's see, I think that's 512. Let me actually do this just to make sure. Fast forward through all of this. 72 plus 78 plus 78 plus 30 plus 55 plus 70. Yeah, okay. No, wait. Gosh, I'm going to do this all over again. Again, you have the technology here to fast forward, which I recommend that you do or use this time. Okay, cool. So that equals 512 divided by 8, which is 64 years old. Okay, so that changed, right? Our first mean was 65.25, and now it's gone down when we remedied this typo, when we put in 76 instead of 86. Okay, so that's fine. That's good. It's not too big of a change. But let's calculate then the median. Let's calculate the median. Okay. So what we want to do is we want to order all of the values again from smallest to largest. So that is 30, and this is where you really want to make sure that you've got everything entered correctly. So it's 30 and then 53, 55, right? 53, 55, and then 70, okay, and then 72, and then, let's see, 76, that new value, and then 78 and 78, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're good. Oops, too many. 1, 2, 3, 4, 5, 6, 7, 8. All right, cool. All right, and then the process, right? We just whittle away. Take off the first one, take off the last one. Do it again. And then we get to these two values here, add them up, divide by how many there are, 2 in this case, right? And it's always 2 when we're working with this median and there's, a tie, more or less. And that still equals 71, okay? So the median age is still 71 years old, okay? Let me highlight that so we don't lose track. And then, we want to do the mode, too. Right? Where, in this case, if we look over here, it's still, sorry, I know you can't see me pointing. If we look over here, the modal age is still 78 years old. Okay, so what do we take home from this? What do we take home? Well, pause the video and think about it just for a second, and then I'll tell you what I'm thinking, okay? Okay, so I assume you paused the video. Here's the deal. Here's the deal. Is that the mean, the median, and the mode are all legitimate ways to summarize a group of data, okay? But one of them, specifically the mean, is more susceptible to outliers. And what do I mean by that? Well, values that are just on the outside, right? So not necessarily large and not necessarily small comparatively, right? But just small changes in the data set, right, can lead to changes in the mean, right? So I'll just say, I'll say it's affected by changing data. And then in parentheses, I'll put outliers. Because I know we haven't talked about outliers specifically, right? But we will in just a second. But that's the idea, right? Is that if you were to change the data set or add in a new value, the mean is going to change, okay? Especially it's going to change if it's on the outside, right? So more toward the minimum and more toward the maximum, okay? But we see here that the median didn't change when you added or when you changed one of the values, right? Even if you were to add, if you were to take out 78 and put in, for instance, if you were to change that and put in 100, the median is still the same. The mean is going to change greatly, right? If you were to say 1,000, somebody's 1,000 years old in Congress, right? The median is not going to change, right? The median is not susceptible to changes in the data, right? So let me put that back. Cool. Same thing with the mode, right? Now, the median will change if a data point, or if you add in a data point that is closer to the middle, right? When you order everything up. But as far as outliers go, as far as things that affect the mean, right? Those outliers are a big deal, right? Stuff that are closer to the minimum and closer to the maximum of the data, right? Okay. So I'm gonna pause the video again, and then we'll chat about how to visualize data, right? Because we have these summary statistics that are helpful to see, a summary, kind of the spark notes of the data, but we aren't able to see all of the data, at least easily. So I will see you here in just 1 second.